In continuation of previous lecture, so we will discuss about the examples related to the limit. Okay, so we can take any examples. So in which case the limit is exists or does not exist. So here we take one example. So this is the example number 1. So we write down as evaluate limit x tends to 0 and y tends to 0, x square y upon x raised to the power 4 plus y square. So we know that these are the rules. So that means the working procedure for finding the limit. So we follow the step 1, 2, and 3. So here we shall start step 1. So in step 1, so that means first we apply the limit of x. So now we write down the solution. So that means given limit x tends to 0, y tends to 0, x raised to the power 2. So x raised to the power 2 into y upon x raised to the power 4 plus y square. So now when we apply the limit x tends to 0 here, so we see that, so we write down as limit y tends to 0 in place of x. When we put x tends to 0, 0 to the square is 0. So 0 into y upon 0 plus y square. So this we can write down as y tends to 0. So this is y into 0, 0, 0 upon y raised to the power 2. So it gives us 0. So this can be considered as a function f1. And now when we apply limit of y first, so we see that again limit x tends to 0, y tends to 0, x raised to the power 2 into y plus y square. So when we apply a limit y tends to 0 first, so we see that, so x square into 0 upon x raised to the power 4 plus 0, y, this gives us, so limit x tends to 0, so that means the numerator is 0, 0 upon x raised to the power 4. So this gives us 0, so this we can consider as f2. So this is f2. Now, when we follow the third step, step 3 is given as when that means x not tends to 0 and y not tends to 0, so find the limit along y equal to mx or y equal to mx raised to the power n. So now when we put y equal to mx, so when we put y equal to mx, so we see that, so limit x tends to 0, y tends to 0. So x square into y, in place of y we put as y equal to mx, and we write down as x raised to the power 4 plus mx to the whole square. So now here we write down as a limit. So when we substitute the value of y here, so we just take the limit of x only. So this can be written as x q into m upon x raised to the power 4 plus, we write down as m square into x square. So m square into x square. So this we can see that. So that means in denominator we can take a, so we write down as limit x tends to 0. So this is x q into m, x square taken as common. So we write down x square plus m square. So x square plus m square. So we write down this as limit x tends to 0. So x square to x cube is cancelled by x. So we write down the x into m upon x square plus m square. So when we substitute the limit of x tends to 0, so we write down as 0 into m upon 0 plus m square. So this gives us 0 upon m square. So something upon 0 upon something, that means that gives us 0. So this we can denote it as function f3. So this denoted as f3. Now again we put by putting y is equal to mx square. So we take y is equal to mx square. So now we see that. So limit x tends to 0 into y tends to 0. So this gives us x square into m x square upon x raised to the power 4 plus. So m x square to the whole square. So here we take the limit of x only. That when we substitute the value of y, so just we write limit x tends to 0, and numerator we can write down as m into x raised to the power 4, or denominator x raised to the power 4 plus m square x raised to the power 4. So here we see that, so limit x tends to 0. So this gives us m into x raised to the power 4 upon x raised to the power 4 taken as common. So this gives us 1 plus m square. So x raised to the power 4 to x raised to the power 4 cancelled. So this is purely constant values. So we write this as limit x tends to 0, m upon 1 plus m square. So this gives us m upon 1 plus m square. So this is the function 4. That means f4. So we say this is the function f4. Now, as per our working procedure, we see that if the value of the limit does not contain m, so then we can say that the limit exists. If it contain m, so then the limit does not exist. So here we see that all the functions. So we conclude that. So we write down the hence. We see that the function f1 is equal to f2 is equal to f3, but not equal to f4. But not equal to f4 because f4 contains m. So we can say that the limit does not exist. Okay. So next example, you can understand. So again, we take one example. So this is the example number 2. So here we take the different example, evaluate limit x tends to 0, y tends to 0, x cube plus y cube. So similarly, we follow the same steps as per previous example. So we write down the solution. Solution, that means we take limit x tends to 0, y tends to 0, x cube plus y cube. Now here we first put the limit of variable x tends to 0. So we write down as limit y tends to 0. So when we put limit x tends to 0, so 0 raised to the power 3 means 0. 0 plus y cube, this equal to limit y tends to 0 into y cube. And when we put y tends to 0, this gives us 0. So this is our function f1. Okay. So we say that this is function f1. So again, first we apply the limit y tends to 0. So we see that the limit x tends to 0 into y tends to 0, x raised to the power 3 plus y raised to the power 3. This equal to when we apply the limit y tends to 0 here. So this gives us x raised to the power 3 plus 0. Okay. So 0 raised to the power 3 means 0. So this equal to limit x tends to 0 into x raised to the power 3. When we apply limit x tends to 0 in this function, so this gives us 0 also. So this is our function f2. Now, similarly, when we put y is equal to mx, about a line y equal to mx, so this can be written as, so that means y equal to mx, so this gives us mx raised to the power 3. So we can write down as limit x tends to 0. When we substitute the value of y, so we eliminate the limit of y. Okay, so just we take out the limit of x only. So this can gives us x raised to the power 3 into 1 plus m raised to the power 3. So when we apply limit x tends to 0, so this gives us 0. 0 into 1 plus m raised to the power 3 equal to 0. So this is our function f3. So this is our function f3. Now, similarly, when we put y equal to mx square. So when we put y equal to mx square, so we see that limit x tends to 0, y tends to 0, x cube plus. So this is y cube means mx square raised to the power 3. So this can be written as limit x tends to 0. So this is x cube plus mq into x raised to the power 6. So x raised to the power 6. So then we see that, so when we take xq as common, so this gives us 1 plus mq into x cube. So now when you substitute the limit as x tends to 0, so this gives us 0 into 1 plus mq into 0. So this equal to 0 into something means 1. So 0 into 1. So this gives us 0. So this is our function f4. So we see that. So here, yeah. Hence, we can say that the function f1 is equal to f2 is equal to f3 is equal to f4. So we can write down that hence the limit exists. Okay, so we have taken two examples. On the basis of these two examples, first one shows that the limit does not exist, but second case shows the limit exists. Okay, so hope you understand. So